All right, welcome to 8.7. I believe this might be mislabeled in your notes. So, solving radical equations is going to be 8.7. We are going to talk about the principle of powers, which states if A is equal to B, these are your bases. If you raise both the A and the B to the same power, those will still have to be true. Now, you have to be careful because if you look at this backwards, it could create a false statement. All right, so for example, here everything's good. 3 is equal to 3. I square both sides, 9 is equal to 9. But if you start with a false statement, negative 3 is equal to a positive 3, that's false. And you square both of those numbers, it could turn it into a true statement. This means that when you square or raise something to an even power, you run the risk of taking a possible false statement, because we don't know what the variables are equal to, and turning it into a true statement, which means some of your answers for x might be right and some might be wrong. So we always have to check these. So to use this principle to remove radicals, here we are. We have one variable in the equation. These are straightforward. We won't run into this problem. We run in this problem when you have two x's in the equation. So here we have the cube root of x is equal to a negative 5. I would like to get rid of that cube root, so take the root number 3, raise it to the power of 3 on both sides. This cancels the cube root, leaving you just the x, and negative 5 times itself 3 times is a negative 125, and that is our final answer. Here we have the fourth root of x is equal to 2. So again, we're going to apply the same rule. We're going to take both sides to the power of the root number, otherwise known as the index as well. So those will cancel each other out, leaving you an x, and 2 to the fourth is 16. There's my final answer. Here we have, there's no root number, so that's a square root. So we would want to take both sides to the power of 2. Wait a minute. I'm looking at this negative 7 being squared. That's going to change it from a negative to a positive. That's not good. Square root principle says that all square roots must equal a positive number. So this is not possible. So this would be no solution. Again, here's one of those times where we're changing a negative to a positive and making something come true. If you did accidentally square both sides and call that a 49, substitute it back in. The square root of 49 is a positive 7, not a negative 7, and then these two sides aren't equal. They're false, so therefore you know it's no solution. So this is a big step right here for us. We've got to remember that. So when we make our rules for solving radicals, that's going to be number one thing to do, is to isolate the radical to one side of the equation. So get this square root symbol, this radical symbol, by itself, especially when it's an even root. Because then if it's equal to a negative number and you have an even root, you have a no solution situation. All right? So looking at my equation to the right, my radical symbol is the square root of x minus 3. It is not isolated. I need to get rid of the minus 17 and the 2. I don't look at it now and say, oh, it's equal to a negative 9, no solution. Nope, I don't have this isolated yet. So I'm going to have to add over the 17 first. That's going to give me a positive 8. Then I need to get rid of the multiplication of 2 to the front of my square root symbol to get that isolated. So I divide both sides by 2. Now it's equal to 4. So now here's my even root, a square root. That's my radical. It's equal to a positive value. Then I can keep solving. If this was a negative 4, I would stop and say no solution. But because it's an even number, I'm going to go to step 2 by removing the square root with my principal of powers. So we're going to keep going by squaring both sides to get x minus 3 is equal to 16. The square root and the power of 2 cancel. We finish solving for x. We add over the 3 to get x equals 19. Now, one way that I like to grade my work is with a calculator. Okay, so here is a screenshot. You take your answer, you store it for x, and I'm going to show you how to do this on the calculator. You type in the left-hand side of the equal sign, and if your answer is correct, it's going to equal what it says here. All right, so let me go get my calculator off of the other monitor. Give me a second here. I got to finagle it so I can move it over here. All right, here we go. I found it. All right, so here's the steps. I'm going to clear out my steps down below so you can see the steps I'm doing here. So we're going to take our answer 19. Your store button is right here next to the 1 or above the on button. That gives you the arrow that you saw on my screen right there. And then your variable x. We hit enter, and now x has the value of 19 until you change it. So now I go back to the left-hand side, and I type in 2. My square root symbol is above the x squared, so second square root, I type in x minus 3. I have the right arrow to get out of the square root to put in my minus 17. I hit enter, and it says it's equal to -9. That's what it says on the test question. I mean, on your homework question. I'd hate to have you grade your own test questions here. And that tells you that this answer is correct. You just graded a test question, believe it or not. All right, so let's try another one here. Here's 3 times the square root of x plus 7 equals 1. The square root symbol on your x is not isolated, so we have to subtract over the 7. Gives us a -6. We divide by 3. That gives us the square root of x is equal to a -2. Whoa, 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 wait a minute. My even root is equal to a negative number, so that's no solution. You're done. Now, let's say you forgot, and you squared both sides anyhow and said x equals 4. Now you store the 4 in for x, so 4, the store button, x, enter. There's the 4. You type in the left-hand side, 3 times the square root of x plus 7. Old calculators, they put parentheses here instead of a text box. But that comes out to be 13, not a 1. So that tells me that my answer of x equals 4 is false, and it's wrong. I have to throw it away. All right, next example. Here's that fractional exponent. That's a radical. So the denominator is your root number, so we're going to change that to the cube root. The 1 is the power on this binomial, which we don't need to raise it to the first power. So we have the cube root of 2x minus 5 plus 6 equals 3. I'm going to subtract over the 6 because I need to isolate the cube root symbol, and it's equal to -3. So can I say no solution? In this case, no, because we don't have an even root number. 3 is odd. Odd root radicals can be equal to negatives. So this is okay. We're going to keep going. Only if it's even root. No number there. Put a 2 there. 4th root, 6th root, 8th root. Those are even roots. They have to be equal to a positive. So we'll go ahead and cube both sides. Cancels out the cube root symbol. 2x minus 5, -3 to the third power is -27. Again, you can type that into your calculator if you needed to see it. Left parentheses, -3, right parentheses, raised to the third power. Hit the negative key, not the minus key, to get -27. Add over the 5, gives me -22. Divide by 2, x equals a -11. Okay, so calculator check, -11. Store it for x, hit enter, type in left parentheses 2x minus 5, right parentheses raised to the power of 1/3. Old calculators, you had to put that in parentheses, plus 6. It's equal to 3. That's what it says. We know we're correct. Newer calculators, if I wanted to enter that into my calculator, so again, negative sign, not the minus sign, 11 store it for x, left parentheses, 2x minus 5, close the parentheses, raise it to the power. It's a fraction. Remember, alpha y equal to get your fraction text boxes. 1 on the top, 3 on the bottom. Right arrow out of the exponent position, put in your plus 6, hit enter, and it's equal to 3, just like it says on the test or your homework. So now you know you are correct. Okay, now, when do things get more difficult? Notice what's different about all these problems we had here compared to this problem. That's right. There's two x's, one on the inside, one on the outside. This is when we run into that problem of you have to check your answers. So again, we still have to do the same thing as we did here. We got to get the square root symbol or the radical symbol by itself. So I'm going to subtract this 5 over to the left. Now it's isolated. I'm going to, wait a minute, how do I know that this is positive? So what we're going to do is we're going to put a note check here. X minus 5 has to be a positive value. And the only way to make it positive is if you take x minus 5, set it greater than or equal to 0 and solve for it. So that means you add the 5 back over. If x is 5 or bigger, it's positive and not a negative. So that tells me if I were to get a negative 6 for an answer, I have to throw it out because it doesn't make this true. So we're going to keep this on the back burner as our disclaimer. So we're going to assume it's positive and go ahead and square both sides. So that cancels out my square root, x plus 7, but over here we're going to have to write this out twice and FOIL it. X times x is x squared. X times minus 5 is minus 5x. Minus 5 times x is minus 5x. Minus 5 times minus 5 is plus 25. Combine everything together. We get x squared minus 10x plus 25 is equal to x plus 7. We want to set this equal to 0, so we subtract over the x, and we subtract over the 7. We get x squared minus 11x plus 18 equals 0. I'm going to move that up here to the right because I'm running out of room. So here we're going to factor this. Read it backwards because there's a 1 here. What two numbers multiply to be 18 and add up to be a negative 11? Well, 9 times 2 is 18, and 9 minus 2, or negative 9 minus negative 2, is going to be a negative 11. So that factors to x minus 2, x minus 9. X minus 2 equals 0, x minus 9 equals 0. That's our zero product rule. X equals 2, x equals, wait a minute, x equals 2. 2 is not bigger than 5, right? So that means we have to throw that answer out, and x equals 9, that means has a chance to be correct. So we're going to test it. So here my screenshot, kind of my 9 stored for x fell off the screen. So there's the 9. I typed in the square root of x plus 7 plus 5, and that equaled 9 for my x. But when I store 2 in for x, I type in the same right-hand side. Now it's an 8 and not a 2. So yes, this answer doesn't work. We throw it out. All right. Now, here are some nightmare questions that you will see when you get to college algebra. All right. We're not going to do this problem. Okay. I want to forewarn you that these are extremely difficult. There's a ton of work, and I'm just going to run through this real fast and I'm going to cover it up. But this is how much work these are going to need when you get to college algebra. That's a lot of work. So we're going to keep it simple. Okay, what I want you to do in your notes is cancel out the 1. So it's going to look like this problem here. I'm going to bring over my iPad, and we're going to work out the next 2 examples where these are easier to work with. Okay? All right. Now, because we have the radical isolated on both sides, we're going to go ahead and square both sides. So because that 1's not there, we can just go ahead and square both sides, and those square root symbols are going to cancel out, leaving us 2x minus 5 is equal to x minus 3, and we can go solve for x. I would subtract x from here, add 5 over to the other side, and I get x is equal to 2. And if you want to check that real quick, the square root of 2 times 2 minus 5 is equal to the square root of 2 minus 3. We get 4 wait a minute, that's a negative 1. We can only have square roots that are going to have positive numbers in there. So in this case, we have to make sure they're positive. This is why we got to check our work. All right, x equals 2 is a solution, but it doesn't create positive numbers inside of our square root. So this means no solution. You got to watch out for these trick questions here. This one down here, we'll go ahead and square. So your next example, take out that next number. This is in the next example. Take out what the number in front of the x minus 7 square root. You square both sides. Again, notice that will cancel out your square roots. We get x plus 5 is equal to x minus 7. But now when you subtract the x over, you get 5 is equal to negative 7. That's a false statement. So again, no solution. So if you do get an answer, make sure you plug it back in to make sure you get positive numbers. You have to have positive values inside the square root. If they come up negative, no solution. If it creates a false statement, no solution. Okay? So there's our steps for solving radical equations.